Internet traffic is growing exponentially. Data centers generate the same amount of carbon emissions as global airlines. Act now with Sentry Software. Measure the power consumption of any server, any network switch, or any storage system in the data center. Optimize its ambient temperature to reduce the cooling costs. Report the carbon footprint of virtual machines, applications, and services with Hardware Sentry.
Hello, everybody. I am Bertrand, the CEO of Sentry Software, and I'm really excited to be here with you at BMC Exchange to talk about sustainable IT. I'm not going to make promises about the future and how we could potentially take possible actions in 5 years or so, once the pandemic is over, once the economy is ready. No. I'm going to tell you how you can act against climate change in our field, like data centers, IT, etc., and reduce the carbon footprint of our activity. And how we can do this in BMC Helix. So you guys heard the news, you saw the video in introduction, you guys are educated. Climate change is real. To be honest, in the software industry, we tend to think that we are the good guys compared to people in other industries, like oil companies, airlines, car makers, even. But when you do the math, one single small server, like 1U, consuming 100 watts for 1 year, it is, in the US, it has the same carbon footprint as a flight from New York to Los Angeles, or to New York from Los Angeles. That sounds unbelievable, and I'm not even taking into account the production of the server, the shipping, and the recycling of the server. No, I'm just, counting the cost of its operation, like, running in a data center, doing its job of server. But your brain has to take into account the fact that the server is running continuously, 24/7, unless you have uptime issues, and for 1 year, unlike your flight from JFK to LA, which is going to be just a few hours. Every organization in business will soon to be required by governments, by laws, regulation bodies to report on their efforts toward carbon neutrality. And guess who will be monitoring these efforts? The market. Financial institutions, banks, investors, VCs. Who's ready to bet on companies who may not be authorized to operate in 10 years? I don't know if you've heard the news, it went up last month, but Salesforce, for example, announced they reached carbon neutrality scope 1, 2, and 3. Last month. That means that they take into the equation their own providers. So if you want to sell anything to Salesforce, you'd better be a net zero company as well. And if you can't measure it, you can't improve it, as goes the saying. So, okay, a quick side note about that quote. You'll see this quote in many presentations, and especially in business and management, in sales management. And it is attributed to Dr. Edwards Deming. The thing is, he didn't quite say that. He actually said the opposite. He said, okay, I'm the Dr. Deming. It is wrong to suppose that if you can't measure it, you can't manage it. A costly myth. Okay. Anyway, so I left this wrong quote here because it is still true in this particular case. If we cannot measure carbon emissions, well, we cannot enforce regulations to reduce them. And that's the key. So we need to report the energy usage of our data center. You'll tell me, that's easy. We simply need to check the electricity bill, and there you'll have your data. Yeah, well, okay, that's a first step, but how to reduce it? Well, there are different ways of looking at the data center. You can see it as a bunch of random servers, switches, storage systems, and spaghetti cabling. Or you can see it as running applications and delivering services. When you take a server, you cannot do much about its electricity usage. I mean, it's difficult to put a server in battery saving mode, right? Like your phone. But when you look at an application that requires 80 servers to deliver a service to 100 customers, well, you'll probably be able to optimize it, right? So it still gets back to how to measure the electricity consumption of each server, each switch, each storage system, and how to map this to applications and services. Until now, the solution was delivered with traditional DCIM products, data center infrastructure management, which required the physical installation of smart plugs to connect every single piece of equipment in the data center. But not only this is a very expensive deployment, it's also a total nightmare to maintain. Think about it. You need to create a map of physical plugs with logical hosts, which change over time. And that's probably why very few organizations have been able to report on the power consumption of their infrastructure and break this down by application and service. So let's get back to Sentry. I truly hope you guys have already heard about us. I mean, we've been partnering with BMC for almost 20 years. Geez, time flies by. I got my 20 years in BMC community badge last week. Thank you, Matt, by the way. So, Sentry developed and has been maintaining one of the most, if not the most, sophisticated software to monitor the hardware, not the software, the hardware of servers, network switches, and storage systems. It is called Hardware Sentry. This software can discover the electronic components of virtually any system in a data center. You give it its host name or IP address, some credentials, and Hardware Sentry will use various management protocols like SNMP, WMI, WebM, SSH, IPMI, or REST to connect to the system and extract information about its characteristics. Okay, yeah, sorry. I used quite a bunch of technical acronyms. Well, did we lose 50% of our audience? Ugh. Okay, but what I meant to say without scaring the hell out of you guys is that we have more than 200 specific connectors corresponding to 200 specific instrumentation layers, agents, stacks, and by the way, that is an extraordinary intellectual property. Really, it is a treasure. 17 years of continuous research. So we have connectors for Dell servers, for EMC disk arrays, for NetApp filers, for Cisco switches, for HP blades, for Synology filers, for various RAID controllers, specific HBAs, etc. And these connectors will report what the system is made of. its processors, its memory modules, disks, network interfaces, its sensors, temperature, voltages, power, fans, everything there is to know about the electronic components inside the box. Why am I telling you that? Why am I telling you that? Well, then we realized all this information, we normalized it across servers, switches, storage systems, even backup systems and tape libraries. Users could leverage that to report the power consumption of their systems. And once we know the electricity usage, we can derive its costs and carbon emissions globally across the entire data center, no matter the vendor or system types. Suddenly, the difficulty of producing reports across heterogeneous infrastructure is gone. Because let's face it, in real data centers, you'll find various pieces of technology. Heterogeneous infrastructure. Heterogeneous infrastructure. So, the technical components that collects all this information, that monitors the CPUs, memory modules, disk sensors, network cards, etc., is hardware-centric. And it is a KM for Patrol, a knowledge module for BMC Patrol, that is. And it's fully integrated with true site operations management. It's configurable in policies. It provides enriched events. We even created a UI extension inside the component. And this has been true since 2004. And then BMC decided it was time to shadow things a little and created the BMC Helix platform, which really started with BMC Helix Operations Management. We say BHOM internally. This new architecture is quite radical departure from true sites, as you can see in this diagram. And it is notably based on modern and open standards, notably when it comes to metrics. The database holding all the collected metrics is Victoria Metrics, which itself is a sort of clone of Prometheus, with the promise of improved scalability and other niceties like that. But essentially, Victoria Metrics is 100% compatible with Prometheus. And logically, the API for BHOM to ingest data from third parties is Prometheus. Also, logically, BMC Helix dashboards embeds Grafana, which is the de facto standards presentation layer for Prometheus. Maybe you guys don't know Prometheus, so it's the new darling in the monitoring space, or should I say, in the observability space, or should I say, in the OLI space. Why OLI, you ask? Well, because there are 11 letters between the O and the Y, so the acronym is O11Y, and it's pronounced OLI. I mean, it's the same trick as with accessibility, also known as A11Y or Ali or Ali. I don't even know. So Prometheus and Grafana are the new darlings in the observability space. Everybody uses it, all platforms support it. Really, it's surrounded by an active community of developers, and BMC made the right call when choosing this technology for the heart of BHOM. Prometheus is a server that aggregates metrics as time series, and Grafana is a dashboarding tool particularly well integrated with Prometheus because they are kind of from the same family. Yeah, and just so you know, Prometheus was originally developed at SoundCloud and inspired from Google's own monitoring tool, which was called Borgmon or something like that. So we decided to go even further in terms of openness and standards at Sentry, and we adopted OpenTelemetry. What is OpenTelemetry? It's an open framework that defines standards for metrics, logs, and traces. You know, the three pillars of observability. And OpenTelemetry also provides libraries, collectors, and exporters for various platforms. And it is really where all monitoring platforms and observability platforms meet and talk together. It is still a work in progress, but they are really paving the way. I mean, it's really the future of everything around monitoring. Look, aren't they cute? This is a screenshot from their website. I mean, who wouldn't love a framework with two young astronomers observing stars in the sky? So, here it is. Drum roll, please. Ladies and gentlemen, let me introduce you. Hardware Sentry OpenTelemetry Collector. So it has the same features of the KM for Patrol. It's pure software. It's easy to set up. Its configuration is minimal. And it supports more than 200 types of servers, switches, and storage systems. And as an OpenTelemetry collector, it natively integrates with BMC Helix. Let's take a closer look. It's pretty simple. On the left, you have the BMC Helix stack, either in the cloud or the on-prem version, it doesn't matter. On the right, you have the various systems in your data center, your heterogeneous infrastructure. Cisco, Dell, EMC, Fujitsu, HP, IBM, Pure, you name it, running any kind of operating system. In the middle, we have Hardware Sentry, with a single configuration file with the names of the systems to monitor and the credentials. So Hardware Sentry collects data from this mess on the right and exports nicely standardized, normalized data to BHOM, which we can visualize in Grafana. What do you guys want the gory details? Too bad I can't hear you, so let's go deeper. So this is how most OpenTelemetry collectors work. You have an internal collection agent, actually, traditional Prometheus exporter, on the right that collects data from the monitored systems. That's where Sentry, we put most of our code. And that's also the thing that you need to configure to tell it what systems to monitor with what credentials. Then the OpenTelemetry receiver extracts the data from this internal exporter and passes it to the processors. The processors then do some minor operations, adjustments, on the metrics before passing them to the OpenTelemetry exporters. There, we use the official Prometheus remote write exporter that sends the metrics to BMC Helix. See, that wasn't that bad. Did we lose another 50% of the audience? Damn it. But enough talking, let's see how things look in BMC Helix. So let's consider we installed the Hardware Sentry OpenTelemetry collector and we configured it to monitor the servers and storage systems we have in our data centers. The OpenTelemetry collector is running and pushing data to BMC Helix every couple minutes. We're connecting now to BMC Helix and we're jumping right into BMC Helix dashboards. And there we select the Sustainable IT dashboard, which has been pre-built by Sentry. And we're going to select a system. And we see that these dashboards display the monitoring of all electronic components in this system: enclosures, CPUs, memory modules, network cards, controllers, disks, fans, temperature sensors, etc. We can go in each category to get more details. For example, what's happening with the network cards of my server, when a cable is unplugged, when the speed is downgraded from 10 gigabits to 1 gigabit, and even the traffic on each physical interface. In the same way, we can visualize details about the disk, the CPU, the power supplies, etc., etc. By the way, these dashboards are just examples, and you can actually build very easily your own dashboards, leveraging the metrics collected by our OpenTelemetry collector. Then, of course, for each monitored system, we can visualize its power consumption in watts. And we have the energy usage in kilowatt hours, the carbon footprint in kilograms for 1 day, 1 month, and 1 year. Even if we don't have 1 year of data, we extrapolate the data we actually have to get a projection of what the system would consume over a year. So the more data we have, the more precise is the displayed value. And then we went further. Using the power sensor inside the servers, we were able to report its electricity usage, right? But not all servers ship with a proper power sensor. Even less network switches, like 40% of them, and even less for storage systems, like 10% at best. But think about it. The software, hardware Sentry, knows everything about electronic components inside the box. How many physical processors, not cores, how many memory modules, what kind of processor, the disks, their type, the network cards, whether they are connected or not, their speed, the fans and their rotational speed, everything. So we developed a special algorithm that estimates the power consumption of a system, even though it is not equipped with a power sensor. This is unique. This is very innovative, and it's really a technical breakthrough. And it was possible only with hardware Sentry because this software knows enough about the system to calculate this estimation. This makes it the only pure software solution able to report the power consumption of every single system in a data center. And that's something we're quite proud of. So that means that we can provide you with an exhaustive understanding of the energy usage in your data center. Again, pure software with no deployment of smart plugs. For every single monitored system, servers, network switches, storage systems, everything. Also, if we go back to the main dashboards, we see that we have grouped systems into zones. So this grouping can be easily customized to represent data centers, that's a good example, server rooms, or even applications and services. So for each zone, we have its annual electricity consumption in kilowatt hours, its annual cost in dollars, or whatever currency you may use, and its annual carbon footprint in metric tons. So we can customize the settings depending on the data center and its and our electricity provider, the electricity price, in dollar per kilowatt hour, the carbon density in grams per kilowatt hour, and the power usage effectiveness, the PUE, of our data center, which itself can be calculated as the ratio between that value displayed here and the amount indicated on your electricity provider invoice. This is the kind of reports you will want to show to assess the carbon footprint of your IT and set goals to reduce it. Reduce it? But how? Let me explain. If you've ever visited a server room, a data center, you've probably noticed one thing. It's freezing in there. Well, it's noisy and freezing. And why is that? If you ask a data center administrator, they will tell you, I don't know, because these systems run better cold than warm, right? Because Linux is a penguin, for a reason, right? Well, the reason, I'm telling you this dirty secret, it's because they don't know. I mean, if a system is running just fine with a room temperature of 64 degrees Fahrenheit, 18 Celsius, it's probably going to run just as fine at 65 or 66, that's 19 Celsius, right? What about 68 or 72? That's 22 Celsius. But in Hardware Sentry, we happen to discover and report the value of every single temperature sensor in these precious systems with their alert thresholds. Because, the temperature on a disk is not the same as, on a GPU, which is much, much warmer. So for each system, we are able to calculate what we call its heating margin. How much the temperature could be increased before reaching the first warning threshold. And we can aggregate that for an entire server room. And that tells the operator by how many degrees they can theoretically increase the temperature of the room. An increase of only 4 degrees Fahrenheit represents a saving of 10% on the energy just dedicated to air conditioning. And the cooling systems typically represent 40% of the overall electricity bill. So, in other words, 40% of the carbon footprint of operating a data center is for the air conditioning systems. Yeah, 100% of the energy consumed by a processor comes out in heat dissipation. 100%. That's just physics. So if your server consumes 100 watts in electricity, you will need another 100 watts in cooling, for the cooling, right? Actually a bit less now if you have more efficient cooling systems that we find in modern data centers. But in our estimation here in this graph, we assumed a data center with a PUE, power usage effectiveness, of 1.6, which is not that bad. If your server room doesn't use passive cooling or similar techniques like that, you will gain even more. So let's go back to our dashboards in BMC Helix. For each zone, and again, this can be totally customized, we show you a calculation of the ambient temperature of the zone, based on the sensors inside each monitored system. And we can see the corresponding heating margin of each zone. So there you have it. I can now advise the data center administrators to slowly, yes, slowly please, increase the temperature of these server rooms and thus reduce the energy spent in the air conditioning systems and thus improving the power usage effectiveness of my infrastructure and thus reducing the carbon footprint of my data centers. It will not decrease the energy usage of the servers inside the server room, but it will reduce the overall energy envelope. And by the way, that's what Google did with its own data centers. They raised the temperature to, wait for it, 80 degrees Fahrenheit. That's 27 degrees Celsius. And now, they can claim they have the lowest PUE worldwide, the best. It is something that can be done actually by every data center in the world. No, let me take that back. It's actually something that must be done by every data center in the world. Okay, and now just for fun, here's our heat map. Okay, so it's an actual heat map as each square represents an actual temperature sensor and not a count of events. So you tell me this is pretty, but totally useless, and you'd have a point. But this giant grid shows every single temperature sensor in our infrastructure, coming from very different systems, from different vendors, through different protocols, all normalized. Now, technically, this is a piece of art. And well, really, it is a piece of art, right? And I like it. It's beautiful, right? There you have it. So version 1.0 of Hardware Sentry OpenTelemetry Collector is available now on our website. So you can download it now and give it a try. We're working closely with the BMC R&D and product management to ensure the smoothest experience integration into BMC Helix. And we're not done yet, we know. So there are a bunch of updates coming down the road in the upcoming weeks. I expect a series of 1.x versions soon. So I hope you guys learned a lot from this session. We have a booth here at Exchange. So please, come visit the team. We can discuss, any question you may have. We can demo the product live. I know I do not need to insist, but reducing the carbon footprint of our data centers is critical to our future. It may have been difficult in the past, but now we have the tools to do it. So let's act now together. Again, thank you for joining us today and enjoy the show.